Hey everyone, in this video we're going through a Next.js crash course to learn how to build a front-end application for our Solana apps. My name is Josh and it's been a while, but this channel's mission is still the same. We are out to accelerate the real transition to blockchain technology. In this video, our objective is twofold. First, we're going to learn about Next.js concepts, and second, we're going to build a basic crypto information app with Next.js. More on that later. So what we will not learn, we're not going to learn how to use TypeScript. We're not going to learn React, and we're not really going to learn how to use Solana or Anchor. So, the big question then is, well, you're a crypto channel. Why are we doing this then? Good question. I don't know. It's kind of too late now. I made the project. I made the slides. I already went into the rabbit hole and sunk hours and hours into this. So, might as well do it. My bad. Moving on, this video is sponsored by myself. Check out this playlist. This has all the actual Solana development material that you're interested in. Don't worry, in theory, these videos will build up and we're going to create an end-to-end front-end application. But this is just the first of a couple of videos that I intend to do that talks about creating the front end with Solana. So let's get started. What is Next.js exactly? Well, it's essentially the React framework for production. In React's own words, not Next.js, I'm read through this because you guys can pause the video and read it yourself. But Next.js is essentially just a framework that has a lot of the basic things you might need to have a app in production, including things like styling and routing solutions. It has things like Babel and Webpack for compressing your files into smaller bytes, and things like that. We'll go a bit more into that later. But it's a very lightweight and very unopinionated solution, so you can still customize it to however you want it to be. So what exactly does Next.js provide? Well, it's a framework that provides React routing, which is important for single-page applications. If you want to load a specific part of your web application, normally you have to navigate on the web page, but you include certain pathing in your URL, and then your application will load the appropriate components. There are built-in code bundlers like Webpack and code transpilers like Babel, and these are good for bundling and minimizing your code so that it's small and very fast and easy to download from the servers. Very important for production. And another powerful thing is it offers statically pre-rendered pages. We'll go into a big deep dive into this. This is very important. After this video is done, you'll know this concept very well. And this is important for one, performance and search engine optimization, which is how Google and other search engines can find your app more easily. And of course, Next.js also provides client-side and server-side rendering. More on that later. And it's also a full-stack solution that provides you the capability to write server-side code on the APIs to connect your React app to your database of choice, whether that's a MySQL solution or a MongoDB, and so on and so forth. And of course, there's a lot more that I'll never be able to cover nor understand. You're welcome to dive and learn more. So why use Next.js? I took a couple of examples, but comparing Next.js to React.js, Next.js provides a bare-bone framework of all the industry toolings like we already talked about in the previous slides, and that's why it's more powerful. If you really want to customize everything yourself, then there's absolutely nothing wrong with just going with a vanilla React.js solution. But since we're all good developers, let's not reinvent the wheel and just use Next.js until someone else smarter and better comes down and replaces it. And another more competitive example we can make of Next.js is Gatsby.js. In React's own website, it says that Gatsby is the best way to create static websites with React. It promises the fastest load time of your pages, essentially. But that was many, many, many years ago. These days, a lot of things have changed. So one, technically both solutions, Next.js and Gatsby, can be used for static site generation, or SSG. Before, Next.js used to be known to be able to do server-side rendering better, but these days, Gatsby also supports that. So it's pretty even there. Gatsby is more opinionated, such as how they force you to fetch data with GraphQL, where right now in Next.js, you can do the same thing if you want, but you can also use other options if you want to. Gatsby also has more opinionated plugin solutions, but the most important fact to me is Gatsby's popularity is waning against Next.js. For example, look at this Google Trends. You can see that Gatsby.js, the blue line, has been, you can probably see it bump up a little bit and maybe drop down. You can't really tell. But if you look at Next.js, the interest over time for it just far outstrips Gatsby, and it just kind of blew up. Now, another solution we compare Next.js to, because let's have three things, is Redwood.js. And Redwood.js is another highly opinionated full stack framework that also provides many built-in benefits. I've actually used this for one of my past projects just for fun, and I was actually quite impressed with it. Just like Gatsby.js, it has a strong opinion-weighted solution to use GraphQL, but it also includes some other things, UI testing with Jest and Storybook. It also comes with authentication solutions and very powerful command line interfaces to generate components to get started. That last one is actually like super good. I really enjoyed it. But one thing I will note is that it does not have server-side rendering. So there's nothing wrong with any of these solutions. I personally just went with Next.js just because how lightweight and unopinionated it is. But you can't really go wrong with any of these other solutions that we talked about. Well, except for maybe just go vanilla React.js. Like, come on, let's not reinvent the wheels, guys. All right, so now that we decided that we want to use Next.js because, well, why else are you watching a Next.js video? Here are some of the things that we're going to learn. We're going to learn how to set up a Next.js project. We're going to learn about page routing, so we render certain parts of our components based off our URL path. We're going to learn about some of the built-in components that Next.js provides us. We're going to learn about data fetching. When I say data fetching, I'm actually going to talk about some of the features we mentioned earlier, like static site generation, server-side rendering, and then we're going to talk about API routes, which is the backend that Next.js provides us. So let's get started. So the first thing you want to do is you want to create a project. So prereq, I'm sure we all know how to install things. So you need to get the latest version of Node.js installed, Node version 12. And then to set up, we just use the command npx create next app -- TypeScript because, be cool, okay? Let's not be lame and use vanilla JavaScript. And then we give it the project name. Once we have the project built, we just do npm install, npm run dev to start your localhost, which is by default port 3000. So let's quickly do that. I'm going to pull up my command prompt. Let's make this bigger for us to see. And I'm going to my Git folder and let's just copy and paste the command. So that's npx create -next-app TypeScript, and I'll just call this project crypto info. Yeah, because we're going to make an app that later shows you how to get crypto information and get price information. So just follow through the process, and I'll see you when this is done. All right, it's done. So let's just do a npm install. Yeah, let's go to the project first, crypto info. And then we do an npm install to install all of our dependencies. And just wait for that to finish. Oh, it's already done. Okay, great. And then we do npm run dev. I remember when it used to just be npm run. I guess it's npm run dev now. Okay, great. As you can see right here, the localhost is open. So we just copy this link and let's go open this slide and we'll just visit localhost. And then bada bing, bada boom, we have our Next.js application. So there's nothing really there yet. It's just a page. We can update the page by going to pages/index.tsx, but let's go back to our slide first. But before we open the project, let's understand the basic file structure of Next.js. So we have our public folder. So this folder contains all of our public-facing files like pictures, favicon, components we're not really going to use in this video, but they can contain all the reusable UI elements that we might make, like buttons and inputs and things like that. Pages is interesting. We'll talk a bit more about this, but Next.js uses a routing system to create the URL path based off of the name of your files. API is a little bit different because these will be our backend endpoints that we can call. We'll talk more about this near the end of the video. And we'll have this underscore app.tsx. We'll talk a bit more about that later. And that's it for the pages folder. Next up, we have the styles folder. Hopefully it's not a surprise for anybody, but styles folder holds all your CSS. There are global CSS that affects everything. And there's also component-specific CSS that we can use for specific, components. And of course, finally, we have the package.json. This is where we install all of our dependencies. So let's quickly open our project for this. So you can use any IDE editors of your choice, but I like to use Visual Studio Code, as you might know at this point. The quickest way to open your project is just go open folder, go to where you hosted your folder. For me, that is get crypto info, and on the root directory of your Next.js project, just hit select folder, and there we go. We have the project. Now I'm going to make this bigger for us. And as you can see, here's the file structure that we discussed. We have our pages, we have public, we have our styles, which includes our CSS, package.json, and you can pretty much ignore the rest. So just for a quick edit, let's just delete everything inside our index page. And we just, let's say hi. We just leave hi as a text. Well, I guess we need to wrap this in something. Okay, hi. So one nice thing about Next.js is that because you started the environment, it does hot reloading, so any changes you make get instantly reflected. So I go up here and you see everything we had before in our Next.js has been eliminated. Now all we have is this hi text. So now that we have the high level overview of the file structure, we're going to actually step into all of it. All right, so the first thing I want to talk about is page routing. So Next.js uses a file system-based routing. For those familiar, it's kind of similar to React Router. It allows the navigation to different parts of your components based off of your URL path. So some of the benefits that we get for using Next.js's page routing is that we decrease the bundle size because we no longer have to include the React router as a dependency. We have some other solution that Next.js has. Another benefit is that instead of using like a routes folder like React router, you just use your file system to define what the URL is, and maybe that's more clear and concise. And maybe this is just a plug for themselves, but it allows you to utilize some of the latest improvements that the framework provides you. All right, so there are two types of routing. We'll quickly look into that, but they are static pages and dynamic pages. So let's take a look at that. So we have static page routes. This is the file system routing that React has. We put all of our pages inside this pages folder. And if we have an index.tsx, this index file will represent our root URL path. And of course, if we create another folder file called about.tsx, this would correspond with the /about URL. And of course, we can also add in our folder. So let's say pages/random and then /page. This would map to the URL path random/page or localhost/random/page. To create a page, it's pretty straightforward. You call you name the component whatever you want. It extends the next page object that Next.js provides us. And then just like in normal React, you just return the DOM elements that you want to render. And of course, you want to export the page that we create so that Next.js knows how to render it. We already have something like this, so I'm not going to dive into it. So earlier, I mentioned something about a _app.tsx. You might be wondering, well, what is that? How does this map to anything? The short answer is actually it doesn't. So what Next.js does is it has certain file names that map to some special functionality. The _app file is an app component that initializes your pages. We'll take a quick look into it later. But essentially is if we want to have any shared functionality, like for example, styles that we want to add into all of our components, we will put it inside the app file. So some use cases is we persist layouts. The layouts is a big one between different pages. Maybe we want to include additional data with React context. Very important point. This is probably like the only reference to Solana in this whole entire video. Is that we'll be using it for phantom wallet integrations so that any page that we create will have access to this information. So for those not familiar with context in React, if you don't know React, this might be tough, but you essentially think of React context as a way for us to store variables globally, and then we can access it anywhere inside of our pages and components. And of course, like I mentioned, we can add global CSS that'll be applied everywhere. So we take a quick look at what it is. Move my head. This is what the app component is. It's basically a wrapper that takes in two parameters. There are components, which is the page that we're rendering, and page props, which is just the components that we're passing into the page. Unless we do something special with prefetch data, talk more about that later. It'll just be an empty object and we're just passing things through. So let's take a quick look at the example. So if you go here, we open up our app.tsx, it looks exactly the same thing. So I will prove to all of you that this is a global file. So let's say that I want to, add another div, and then just add a button, right? And let's say, so now if we go back into our localhost, you can see now that we have this everywhere button. And if, let's say, to prove my point, let's create a new file and we'll call it about.tsx, right? I'm just going to copy our index page and I'll just call this about. Okay, so I can't make the thing bigger, but I'll just type /about because our about.tsx maps to this page. Or now we load this new page and this page has about and we still have the everywhere button because we set it up globally everywhere. All right, so for now, let's just revert this because we don't really need it. So hopefully that gives us understanding what static routes are. Let's look at dynamic page routes. So dynamic page routes is for pages that have dynamically changing data. For example, like a post ID, a user ID, a blog post ID, and things like that. How do we load these type of information? Example here is we can have a pages/user, users to folder, and then we have this id.tsx. So what these brackets are essentially is these represent the dynamic data. It means that whatever the user enters here is referenced to as an ID. So this can be used to represent /user/1, be user ID 1, and we can use it. It can also represent /user/2, which is user ID 2. We can have multiple dynamic data, like in this example with the post. We can have a post ID and a comment ID, which you can see is represented this way. So here is what it might look like. This is one way of querying the data. We create a next page component. The one big difference here you see is that we use this use router hook that Next.js provides to us, and this will give us this router object. And inside router, we have a query, which allows us to access the URL param of the page. And then from the query, we can deconstruct and pull out the URL params that the user entered. And then from there, you can just use it to render whatever you want to do with it or add any logic. For those who are curious, if you want to see what the router looks like, the router is a base router object, and it has all these parameters that you can see. The one we used is query, which returns a parsed URL query. And if you're curious, you can look more into that yourself later. So let's implement a very basic dynamic page route. And because this is technically a crypto channel, and don't ask why we're doing a Next.js tutorial, but it is what it is. We're going to create a dynamic page route that would essentially just take in the name of your crypto and then we'll just print it to the page. So let's do it. So just as before, we go to pages, we create a new file, and we'll just use brackets, coin, close bracket, .tsx. All right, so let's just copy all of this. We'll call this page, it doesn't really matter what we call it, but we'll just call it coin. It's coin page. And so just like before, we need to get the router. So const router equals use router. And nice thing with VS Code that I love about it is if you type it, it'll give you the auto suggest, and then you can just import it. All right, okay, so we have the router. So now we need to deconstruct information. So because we have our dynamic variable is coin, we just call coin to get what we're looking for. So router.query. All right, cool. So now we just want to show the coin. Let's just make this a div, and we just do these curly braces so that React knows we're using a variable, and we give it the coin that we set up. So now if we go back to our page and we go to, let's go Ethereum, we load a page and it reads Ethereum. Likewise, BTC gives Bitcoin. One thing I will say is that this is technically a catch-all. So if you need to account for the fact that the users might enter something that's incorrect. For example, I can just do any random strings and it'll just print that out. But yeah, that is it. All right, good work. We have finished the first part of this video. We have many, many more things to implement, so let's get going. All right, next step, we're going to learn about common Next.js components. So what do I mean by that? I'm just talking about basic replacements for existing HTML components. For example, one thing we have is this new link component. So let's say I want to use the anchor tag to redirect someone to somewhere else. Very typical stuff. Instead of using the a tag that we mentioned, we use this new link component. And the benefits of doing this is that you might notice that when we went to a different page, when I typed it in the browser, went to a different page, the page fully reloaded. Instead, if we were to use the link tag, we would do client-side re-rendering, which is much faster than having to reload everything. Pretty basic stuff. I'm sure we are all intelligent people. We don't need to go through an example using these components. So, use your link tag instead of the a tag, straightforward enough. We also have other HTML components. Some of the common ones that are mentioned I've seen is the head tag for your headers, images, and script. Let's talk a bit about each of them. So head. Head replaces the head tag in HTML, and it's used for SEO purposes. So what usually goes inside your head is things like your title and your fav icon, so that the search engine can find out what this specific page is about. So what is the benefit of using this component? So when might this be useful? You might imagine a React component, we have a lot of shared code. Maybe we have a shared page, and inside that shared page, based off of maybe that's some dynamic routing data that we provided, so we render different HTML. We might render different components, and based off those different components, we might actually have a different app. By having this head component, we can easily set the head tag inside our page to be whatever specific logic we want. So if I'm, subpage 1 and I wanted to have a different title from subpage 2, I can use this head and it will set up the correct metadata for us for SEO. Another more maybe common thing that you all might be more familiar with is images. So there's the image component. It pretty much replaces the image HTML element. Here's an example up there. We just reference golden retriever puppy.jpg. You have all the same HTML elements, attributes that you might expect. Your alts, your height, your width, and so on and so forth. One thing I do want to note is that this / golden retriever puppy.jpg is not actually located on the root directory of your project. It's actually located in the public folder. So why would we want to do something with this? As always, Next.js provides some benefits and optimizations. The first one is has improved performances. The image component has some responsiveness to it, so it provides the correct image format for whatever devices you're using. Has visual stability, not too sure on that one. Has faster page loads. It has some optimization where it only loads the image when it is in your viewport. So specifically, as you scroll through the page, some of the images won't be rendered until you see it. This helps with your initial page rendering when users visit your website. So you see, this is why Next.js is built for prod. It has some asset flexibility, on-demand image resizing, and things like that. So maybe when you change the size of your browser and stuff. But the big key takeaway here is that the image component is great for performance. So another one is script. So script is normally in HTML, is used to load JavaScript. Often you use it to load third-party apps like Google Analytics, maybe Facebook ads, and things like that. Use it pretty much the same way as you use a normal script, but there are some benefits that Next.js provides you with how you load these scripts. So as you see, we have this strategy, lazy unload. And what goes into this strategy, there are, I think, 4 types of strategy in use. So there's before interactive. So this means that I have to load the script before my page is interactive. So the page loading will be blocked on you needing to download this library. There's the default, which is after interactive, and it just takes its time to load after your page loads, ideally very fast. And then there's lazy load. So this would only load when there's any idle time or when you absolutely need it, then it'll start loading it. But until then, it won't do anything. So this is very great for performance. And then there's another beta functionality called worker, which uses a web worker to help load your script. I wouldn't worry too much about this one. I think the big three things you should worry about is the first three. But so these are some of the basic components that you should know about, but I'm sure you can look up the documentation and learn more. I won't dive into any more of these. So the next big thing is styling. How do we style our components? So I previously alluded to it, but there are two ways to style. There is a global CSS file that you can use that would apply to any components that matches your class names, your ID, or any selectors that you might have made. And then there's a CSS module, which allows you to create a specific CSS style that you can append onto your components. I'll show you how that's done later. A fun quick note, Solana actually provides a neat Anchor front-end template that we will go through in the next video that uses Tailwind CSS. Alrighty, so first thing is global CSS. We already saw where that's located at. That's it's in styles.global.css, and it's imported in the app component that we mentioned. And like I mentioned earlier, it's like a normal CSS style sheet. Everything that you write in there will be applied to any HTML element that meets the requirement. So let's take a quick look into that. Okay, so first let's look at our app component. So as you can see, we have our style. Our style is in styles global.css, and in here, in this code right here, line 1, we're actually directly importing it. And so by importing it, we are applying this global, everything inside our global CSS in our app. So let's say, no, these are some of the default functionalities, but let's say that we have inside our coin, we'll call this, let's make another one. Let's call div class name, oops, and we'll call this global coin. And we'll just wrap all of this inside another div so we don't get any compilation errors. We can now go to global CSS, and we can just write a CSS selector for a global coin. And let's just say we want the background to be red. And that's it. And now if we go back to our component, we can see right here that now, or come on, let's since we're Solana channel, let's do Solana. We can see that this whole the first div that we had that applied to CSS is now red. All right, so I think that gives us an idea of what global is. So the next thing is we have CSS module. So maybe we don't want to apply a rule to everything because you can see how that can be complex and messy, especially once you scale and get a large, bigger application. Another way you can handle this and keep things more logical and componentized is use component level CSS. This will essentially generate a unique class name that you can apply to your DOM elements, and I'll show you what that means. So an example we have is I think it's actually got home.module CSS, but let's say we make up another file called button.module.css. The name is arbitrary, but no, I like to name it this way. We just define our class names that we want, very similar. We have our button style, and that just set whatever has that class name to have the background color red. So this is how it's used. So let's say we have a button component. You just import the styles module that we created. We import it and call it styles. And then whenever we want to use a specific style, we just go to the HTML element we want to use, set the class name, and just call styles.the name of the CSS that you created. And that's it. That's how you create a component level CSS module. So let's go through a quick example of that one. So yeah, we have a home module. Styles, let's just make another folder. I'll call it coin.module.css. Local coin. And we'll set the background to be blue. And now let's go to our component over here. And so we can just rewrite this. So instead of using styles from the home module, we'll just use it from the coin module. And then we'll just go to our second div that we created already, and class name. We will use the curly braces because we're using a variable. So we just say styles, and no, it doesn't autocomplete, but we'll call it, what do we call it? Local coin, I think. Local coin. So now we have this. Let's go back to our example, and boom, we have a blue div. And that's how we create local styles for our CSS. The great thing about this is that we keep all of our code centralized in one location, which is this coin module CSS. We don't need to stuff everything inside this one gigantic global style sheet. So that is that. All right, so easy mode's over. Now let's talk about some of the more advanced concepts of Next.js. So what is pre-rendering? Next.js generates HTML for each page in advance during load time, or when you do a npm build essentially for production. And what I mean by that, I mean it literally generates the HTML page that you would visit. So the benefits of that is that now we have better load performance and SEO benefits. I'll talk a bit more about how that works later and why you get these benefits. So there are two main strategies for pre-rendering. We have static site generation, and then there's server-side rendering. There are other rendering strategies that we'll also dive into, like incremental static regeneration and client-side rendering. The first thing, what is static site generation? So static site generation, that's the default option, is for creating a static page where the content doesn't really change often. So to be clear, static site generation is not only meant for static routes, it can also be used for dynamic routes, the dynamic routing that we created earlier. We'll see more about this later. But some examples that we can use static site generation is, marketing pages, blog posts. I see that'd be dynamic, but we can still use SSG for it. It's recommended to use SSG for it. E-commerce, and maybe static help and documentation page. A bad use case of static site generation is for things like social media websites or like Twitter, for example. We'll talk a bit more about this later, but anything that changes constantly, because we can only cache our data for the first time, and we'll see why. Here's the page that I shamelessly stole from Next.js's documentation. Static generation essentially is it generates your page from build time and is reused for each request. And I think the next slide will make this more clear. So when you're ready to take your app to production, you do a next build. It generates the HTML page to be consumed. And then every single time the user makes a request to that endpoint, your index or homepage or your blog post, whatever, it would reuse that same HTML. And so you might be thinking, well, that makes sense, but why might it be problematic for Twitter and other sites like that? We will discuss that shortly. But before that, let's talk about how we get data for our static pages in the first place. Next.js has a functionality called getStaticProps. It's Next.js's way to fetch data for the data generation. And we'll see why this is a problem for generating dynamic pages like Twitter, and why it's good for things like a blog post, which are static. So how it works is that getStaticProps is a code that is ran on the server side. And what it does is whenever you do your next build on Next.js and to generate your production page, the Next.js would call your code that you implemented in getStaticProps, and this would do things like maybe get data. So here's an example. So here's a getStaticProps function, and let's say it calls some function to get all your blog posts, or a blog post, and then you just return that as a prop to your component, which then is used. So this function right here is only called once during build time. So if I were to say have an app like Twitter, which is constantly changing, I would never get the newest data because I would just have a static data from the only one time during build where I actually used it. So that's why it's good for things like static things like blog posts and documentation, maybe marketing pages, things that don't change that often, but it's very bad for things that changes like literally by the second. So hopefully that makes sense. The last thing I want to mention is that getStaticProps is only used on your pages. And once again, they are used on the server side. They are not called on the client side. And I guess another tidbit that I didn't mention is that if we're running this on our local environment, it's ran on every request. So hopefully that, so if that's not clear to you yet, let's go through a practical example that help us understand. So we're going to write a function that will get profile information about the crypto of our choice. And to get that information, we're just going to use a great open source API called Messari. And specifically, it has this endpoint right here, get API v2 asset, name of the asset, which in this case it could be Bitcoin or Solana, or a Solana show channel, and then slash profile. And this would give us all sorts of metadata. So actually, let's see an example of that. Let's just go read the documentation. So we got assets and we get asset profile. So we're doing this in JavaScript. That's an example. So let's say, the great thing about these GET requests is that we can just actually visit the page itself. So let's say we go look at Bitcoin. So BTC profile. So now we access this GET endpoint, and you can see we have this gigantic blurb of text. We can see some background information, background right here. Bitcoin borrows from nearly 3 decades of research by academics, cyberpunk practitioners, and hobbyists. And so this is the data that we're going to get from our code. So we're going to write an application that call the Messiah endpoint and just parse some of the data to render on our front end. All of this using getStaticProps. So let's get started. All right, so the first thing we want to do is let's just create another file, and let's just call it btc.tsx. Remember, we're not doing anything dynamic yet. Copy our starting code. Fine, let's start with this one. So the first thing we need to do is we need to find the static props. And because it's run on the server side, it's a asynchronous function. It returns a promise. The promise is takes in a type of getStaticProps result, and the return data that we can define ourselves. And that's the function. And then for now, we just return, let's return this for now. And so the type we expect to return, we're going to return a prop. And for our prop, we will just call it type. Our page will expect 3 types of data. The name of the coin, which I guess is Bitcoin. Its symbol, which is also a string. And the background information that we already looked at when we made the API request. And we'll just call this BTC profile page. And we can define our getStaticProp result, which is this getStaticProps. We get this red error because we're not returning that prop yet, but don't worry, we'll get there. So to get this data, remember this is only executed on the front end. We need to fetch the data from the Messiah API. So what I should have done this whole entire time, instead of typing, is copy and pasted. So we're going to use the fetch function. This is just from the TypeScript. So fetch allows us to make HTTP requests. In this instance, we're making a GET request to the endpoint that we specify. And because this page we care about getting Bitcoin information, it's just statically fixed. We'll learn about dynamic path later. We're just going to directly query the Bitcoin profile, and I think this is v2 now, not v1. Fetch result actually returns us an error promise or an error wrapper or something. So what we need to do is we need to call the JSON, the .json file of it, and this is just a convention that we have to follow. And this would actually give us the data that we expect. And just to check it out if we're curious, we can also just console log the JSON file that we've created. And so now that we have this, we can now return our data. So all getStaticProp result is it's just an object that has a props that we can include, as you can see right here. And that prop, of course, is the prop type that we specified. So what are the 3 things that we need? The name, the symbol, and the background. So if we go back to this data, we want to get the symbol, which you can see is right here. It's in the JSON. We need to get the name, which is right here. And then we need to get the background, which I don't know what that is, but that is right here. So we'll need to look at the console to see why I did what I did, but because I already know the answer ahead of time, first thing is the name of the prop will be json.data.name. The symbol will be this. Okay, and this will return us our prop. So let's just go quickly see what this looks like. Okay, actually, this is slightly wrong. I'll show you what I mean. If we go to BTC, I'll get this error. And then if we actually go inside and look at the command prompt, you'll see that the console that we printed out right here, this whole thing is the result of calling this console log. And the reason why it's on the command prompt and not on the client side code is because this getStaticProp is being ran on the server side. And so if we look at the result, you'll notice that the background information that was used is gone. That's because we're using v2 of this API. When I first made the PowerPoint presentation, it was using v1. So name and symbol is still correct, but now we can just use profile general. So profile general dot background. I'm actually not sure what's in here, so let's do JSON profile general and see what's inside. And let's go back to BDC. Okay, actually loaded, so I assume that was all correct. Yeah, so if we look at the profile general, I assume there must be a background somewhere. And here you go. Go all the way to the top. Okay, background. So, okay, background's under object, so we need background details. So as you can see, I'm doing this live now after everything's been changed. So background details, and that should give us all the data that we need. So now we go back to our page that we're rendering, and we just need to take in the data. And so that's right here, the parameter. So the data we're getting is the BTC profile props. And we'll just do something simple, like let's just create a div, and we'll just show the data. It's straightforward. So we'll just do, we'll just print out one div for each object. Oh man, I don't know why my close tags are always wrong, but there you go. Okay, what's the problem here? Ah, yes, okay. So as you know, so this code will probably compile, but the TypeScript compiler is just complaining because of the type that we give it. We'll look into this in another example, but just for the sake of brevity, I'll just get rid of the infer type and there will go away. I promise you, it will work. So let's go back to Bitcoin. Oh, it already loaded. So there you go. Now we have on our Bitcoin, we have the name of the Bitcoin, the name of the coin that we fetched, name the symbol, and we have the whole background information. As you see, we don't render the HTML. We're literally just printing it as a string. We could do some optimizations for that, but the key important thing here is that we are making a request to the Messari API for the profile information, and then we're converting it to a JSON object, and then we're passing it back to the client side. And so that's what getStaticProp does. So now, whenever I do next build, this code will get executed once, and it would generate the profile information for Bitcoin to be shown on the server whenever a user were to visit the Bitcoin page, the /BTC. And if any of this information changes, let's say if Messari ever decided to change their background information, then because of the way we generated it, it would not be reflected until we rebuild the file and generate a new static page. There are some other mechanisms to get around this. We'll actually talk about that soon. But until then, just keep this in mind. Cool. Okay, so we got static props. Next, let's talk about how we do static site generation for dynamic routes. As we recall, dynamic routes are like the blog posts. You might have blog post ID 1, blog post ID 2. So how would we handle that situation? Well, luckily for us, Next.js has a solution for this. So to handle dynamic routes, we need to define something called getStaticPaths to specify the actual pages that we want Next.js to support and generate the HTML on build time. The paths that we set, as you see right here, the getStaticPaths, there's a function we call the getPaths, and this path essentially just say, hey, of all the possible input the user can send, we only want to support maybe like, these 5 posts. So what Next.js does is with these, let's say 5 posts, it would call getStaticProps with these 5 posts. and then it would generate the HTML for just those 5 posts. Anything else, we just get the error page. So now that we understand static paths, let's actually implement something with it. So for this part of the video, we want to create a page to show information about not just Bitcoin, but any crypto that you mentioned using dynamic routing and getStaticPaths. So just like before with the Bitcoin, we're going to use Masari to get the cryptocurrency of our choice's profile information. All right, so let's just create a new folder because this is kind of getting cloudy. So let's just call this page profile. And so inside profile, we're just going to create a new URL, and we'll just call it profile tsx. Coin profile? Yeah, let's go coin profile. Let's do coin profile. Probably should have called everything in caps, but it doesn't really matter too much, I guess. Okay, anyways, so once again, let's just copy everything we wrote in here. So let's do some renaming. So this is coin profile props. And there we go. So our getStaticProp is almost the same, but we will make some updates. But the most important part is that we need to define the getStaticPaths. And so underneath export const, and actually, you know what? For the sake of time, I'll just copy and paste the method signature. So we return a getStaticPath result, and we'll just import that. Make sure that's not the same as getStaticProp results. And the expected type that we are going to get from this is the URL param. And so that would be a interface, and this is quite involved for me to get the proper typing. But essentially what this is that I'll call this coin profile page params. But these variables is the name of the URL that we set right here. So this is just coin profile. And it extends parse URL query because if we want to use this in the other locations in the code, we'll get there soon, don't worry. The compiler will complain that other objects are missing. Like the code will work, but you'll just have these red squiggly lines, which we don't want. So the easiest way I found to get around that is just to create an interface of the page param that you want and extend the parse URL query. Now that is over, we will just use this. Now, of course, we don't really need this type. We could literally just return anything, but for the sake of type safety, we're doing this. So how we do this is we just return a getStaticPath result. All it really has is it takes in two things. It takes in an array of paths, which includes essentially are the URLs, which in this case will be the list of crypto that we support searching profile information for. And it also returns something called fallback, which is how we handle situations where the user provides data that we did not account for. We'll talk about this in a later section. For now, we'll just set it to be false. So we need to get our paths. So there are multiple ways we can do that. It might be saved on a config file somewhere in our code that we just access, but in this instance, we're just going to hard code it. What I'm going to do, value over here is actually a coin profile. Okay, so what we're seeing here is we're creating an array of an object. I can't remember what it is. I think it was a path. This path is it's right here. A path takes in a object of params and coin profile page params. So that's what we're recreating up here. We're creating an object right here, as you see by this curly braces, and it has the type params with the value our coin profile page params that we're setting. And we'll see this later, but this param will be used later in the getStaticProps function to query the data. So that's what we're doing. So we're creating an array that it's a fixed array of an object with a param key, and inside that is our coin profile page params. And so coin profile here, we have three things we're hard coding. We will take in any requests for people that are looking for Ethereum, Bitcoin, and Solana. And that's all. So that is saved as a variable called paths, and we just return that inside our getStaticPaths function. Hopefully that makes sense. All we're doing here is we're just defining the 3 URL params that the user can search for. And so now that that is generated, it is passed to our getStaticProps function. So we need to update this code to take in the parameter. And so here I will do some copy and pasting. So instead of getStaticProps, we're going to add the getStaticProps actually takes in 2 inferred types, or types that we can infer. And the first one is the coin profile props, I guess, which is the parameter that this our render function expects. And then the page param, so coin profile params, or I guess page params. And this is the parameter that we expect to receive inside our getStaticProps. So we'll just call this function context. And the expected type we get is getStaticProps context. And that expects a parameter of the coin profile page params that we defined. And the expected return type is the coin profile props that we defined. So now we can reuse this exact same code that we just had. So I'm going to use the, I can't remember what this symbol is, but it's a string literal. It's next to your squiggly line. And it allows me to use parameters in line. So $ curly braces. And well, actually, first we need to actually get the value. So we need to get the params. So context.params. And so the params that we're referencing is literally this code that we wrote right here. So we're getting the param. So I guess what we're passing here is the context, really. But we're calling params, which will return us our coin profile page params, which, you know, if you look up here, it's a string. So now we have the params. And then now that we have that, we can actually query it. So we can say params.coinProfile. And so now we have a dynamic way to call Masari to get the profile information for these 3 coins that we specified. And then everything exactly the same. So let's give this a shot. So if we go back to our host, so now, because remember we moved this to profile, we do profile and then we say BTC. And so if we did it right, everything's exactly the same. If we do Ethereum, now we search for information about Ethereum. And then if we do Sol, okay, this is an error example. So we look for a coal, which does not exist. So as a result, we get a 404 error page. Now if we do the correct thing and do Solana, we get all the information about Solana. Awesome. That is how we handle dynamic routing with the correct typing. By the way, this is very important, all this typing that we're doing. Don't worry, I'll have the GitHub repo in the description below, so you can just follow along from there. But this is how we do the typing. All right, let's go back to the slide. Okay, so that's getStaticPaths. So now let's talk about how we would deal with undefined paths. We kind of just ran into that when I typed in coal earlier instead of sol. So if, as you saw, we type in something that does not exist, we will not render the page. So there are a couple of solutions to this. So the first one is we can set a fallback settings. I'll talk a bit about this later. And this would help resolve the issue. We can use another concept called incremental static regeneration, or we can use server-side rendering. So let's go through some of these. So let's talk about fallback for getStaticPaths. Earlier we saw that we set fallback to be false. What that does is essentially any non-defined path will result in a 404 page. So it makes sense. So what if we set fallback to be true? If set it to be true, for any non-defined paths, we can actually define, well, first we just have a fallback UI that renders while we load. But then once the request, but the important part to mention is that the data is being loaded. So it would actually, if we set fallback to be true, whatever URL parameter we set, the Next.js would actually execute your getStaticProps code that you define and search and do whatever logic you set to get the data that you need. And then once it gets the data, your page will be loaded, and that specific route will be added to a list of pre-rendered pages that can now be cached and stored for everybody else to use. So any other subsequential searches will no longer have to wait for that data. It can just directly access that page, just like, you know, if you already defined it. So very powerful. One thing I will mention is that incremental static regeneration is actually very similar to this, but it also allows you to fetch and update existing data. This doesn't let you do that. It just lets you render something that you did not statically set. Another functionality is fallout blocking, and that's similar to true, but the big difference is that unlike true, which just renders the page initially while it waits, fallback blocking would actually prevent the page from finish loading until you get the data. So maybe very similar to server-side rendering. So we're not going to explore this because, well, this only runs on production and we're only running on localhost, so we wouldn't see anything anyways. I think that's not true. Let's do it. So let's put set this to be true, and let's look at my favorite meme coin. See, there you go. Now it actually works fine. So that is what happens when you set fallback to be true. Let's talk about our next topic. Next, we have incremental static regeneration, or ISR. ISR allows you to create and update any static pages that you create, even after you did it initially. So that's why it's static regeneration. It essentially just rebuilds and regenerates the pages for you. It's actually similar to fallback true, not blocking. But the big difference is that you update the pre-rendered pages. So in our previous example, I talked about how if Masari decided to change the profile background information, you won't see that until you rebuild. If we use ISR, we actually can generate that over a period of time and we can see the changes. So here's how we use ISR. It's actually pretty straightforward. If you go to your getStaticProps function, it actually has another type you can include called revalidate. And all revalidate does is, revalidate takes in a number, which is in seconds. And what it does is Next.js will attempt to regenerate the page whenever a request comes in, at most every 10 seconds. So for example, if user A were to visit, Bitcoin, if this is the first time, ISR will query Masari for the latest data. But then if user B comes in, like let's say 5 seconds later and try to do the same thing, Next.js will not query the data. It'll just use the existing data that user A generates. It's not only until like the 11th second, if user C comes along, that tries to make the request again to the Bitcoin page, will we actually make a request to Masari to get the updated data. But as you can see, this is useful for getting data that updates like, infrequently, but not frequently. Like this still would not be good for the Twitter example. I don't have any particular example in mind, but it's a good in-between of static data and dynamically updating data. So for data that infrequently changes. So now that we have ISR figured out, let's learn about server-side rendering. We went from the full spectrum of static to kind of semi-static, or I guess infrequent, to dynamic data. So server-side rendering is a type of pre-rendering where the data is constantly changing. We make the request every single time, so there's no caching, no saving like in static site generation. The great examples of this is social media, Twitter. Every time I log in, I get new tweets from my friends. So another example, stock apps or crypto apps. I go to coinmarketcap.com every day and see how my crypto is doing. Not well. Anyways, so what are the pros of doing this? Well, the good news is we still have the SEO benefits because for the page to be fully loaded, we still need to make the request and get the data, and so the crawlers will still be able to cache your page properly. But the con of that is you have a slower performance since you have to load, every time you load the page, you have to make the request. So that could delay the whole loading experience if you have a lot of things to download. So of course, I stole this again from Next.js to illustrate what happens. So unlike static site generation, which we can look at over here, where we generate the page once and everyone just queries that same page, server-side rendering, every single time a user makes the request, we make a new page and send that back to the user. Not as scalable, I guess you can say. And so here's how we do it. If you want to implement server-side rendering in your code, you use the getServerSideProps function, or you define the getServerSideProps function. As you might expect, it's only executed on the server side. And the page never loads until the request is finished and passed on to the client. One important note that Next.js did say is that don't use any API routing, API routes. An important thing to know is we don't use API routes. And to clarify, when I say API routes, I'm not talking about the URL pathing that we're talking about. I'm talking about actually defining server-side API routes that Next.js allows us to do. We should not use those inside SSR because they're both actually ran on the server, and it's not as performant because you're just making one server-side call to another server-side call to do whatever you want. Just use the getServerSideProps. And so just looking at an example, it's pretty much exactly the same thing that we've done with our getStaticProps. We just, fetch some sort of data, get the results, and then turn it into a data that we can actually use, and then, return it into some props. And then we just use that inside our page render function. So let's get to the fun part. So let's be honest, crypto's cool. Developing on this is cool. We're on the frontier of Web 3.0, but what's also cool? Making money, which has not been doing so hot in the past year or two. So now, taking everything we know, let's create another dynamic route that would actually get the price of the crypto of your choice. And we're going to do that by using the sorry, I think this picture is actually wrong. We shouldn't be using this. Gosh, okay, let's actually look at what API we care about. So if we go to asset, and we just go to get asset, and I believe, let's see, we go to get asset metadata, and if we look at the result type, I should have used this first actually. Okay, here we go. Yeah, should have used this instead of console log. Anyways, so we use the get asset market data to get the price that we care about, specifically the price USD. All right, so let's get started. So let's create a new folder, and I'll just call it price. And inside our price URL path, we're just going to create something else called coin price. You know what? I don't know, I'll just keep it in all caps. So let's just copy and paste. Okay, so very similar. So we'll call this coin price props instead of background. Actually, let's see again what we get. A name symbol, okay, with price. So we'll just include price, and it's a number. Inside our page param, because remember this is a dynamic route, we do coin price page params, and we'll call this, we call this coin price. It's a string, and we just use the correct parameters, and let's just print out the price. All right, so let's get started. So the first thing is we actually don't need these two functions anymore. I'm going to keep one because actually, I'll just copy and paste from my example that I've been working with. So we're going to create a function called getServerSideProps. It's very similar to getStaticProps, as you can see that we have right here. GetServerSideProps takes in allows us to specify two params: the return prop type that we expect and the context that we expect to take in for this code. That is correct already, and we do coin price props, and the context is wrapped inside this getServerSide context. That's all correct. We need to import basically everything I copy and paste, and the result that we pass back to the render function, and the result that we pass back to the render function is another promise, as always, and it's a getServerSideProps result, and the expected type is the coin price props. And this gives an error because I didn't actually return anything, but if I do this, it goes away. Great. Okay, so now let's define this. This is pretty similar to what we did in our getStaticProps, so I'm just going to pretty much copy and paste what we wrote. So just like before, we get context, we get params. So in server-side props, the params is already specified for us. It's just the name of our page, or I guess all the URL queries. Unlike static props, where we get a list of them, getServerSide props only has the one pager loading, so there's no need to return an array. It's just the params itself. And once we have all of that, I can pretty much, actually, it's pretty much the same. So I'll copy this too. Return this, and let's just get rid of the stat props. You don't really need it. So let's update this for it. So first, we're not getting the profile information. And it's not coin profile, it's coin price. Let's go back to our API call we're making. So it is asset metrics. So let's just copy this. Go back to our code. I'm going to paste this here. And just get rid of everything. Take our string lateral results and replace asset key with the name of our crypto. All right, so now we have that. We don't need to console log because now we learned from our mistake. We can just look at the response in the expected type. So we know we're not getting background information anymore. So now we just want price. And what we want is we want data, market data, and price USD. And that'll give us the price of whatever cryptocurrency we're looking at right now. All right, so that should be it for this page. So let's go back and look at our example. So let's go to price and let's look at the price of Bitcoin. There you go. Solid 18,000, 19,000. Not bad. Good buying opportunity, right? Right, that's what I said the last 10 times. Anyways, so cool. Now we're actually dynamically or rendering this code server side. So the cool thing now is, let's say I refresh this. Notice that the value changed. Now we're at 81 cents, 24 cents, 21 cents, 70 cents. So that's great. Now every single time we reload this page, we are calling Masari to get the latest page information. Let's look at some other examples. Let's look at Ethereum. Ethereum's at 1300. Look at Solana, 33. So, it just did 5 cents. Anyways, so there you go. That's how we do server-side rendering. Let's go back to our slide. Another thing that I don't think works on here, because we're just testing on a local environment, is we can also cache our result with server-side rendering. So for performance benefits, we can cache the response that we received. You knew that by accessing the request and the result, or I guess the response. This code right here is just deconstruction. So we're just taking the context and we're just taking the two params that we care about in this instance, which is request and response. So with the response, we just do set header. We set cache control. And these are just normal header, HTTP header stuff, so it's nothing new in theory. And then you just set these parameters, public, s max age, and stale while revalidate. So what are they? S max age. So that's the max age that the response is fresh before we have to make a new response. So, let's say, so in this instance, it's 10 seconds. So on the 11th second, I would query data, and Next.js with server-side rendering will search the response for like the newest Bitcoin price. But that doesn't mean we actually get the newest data. So for the first 10 seconds, we'll still use the old Bitcoin data that we have. So that's very important to note because we're not blocking on that new result. And then we also set stale while revalidate. This is a time to use the stale data while we're requerying the background for the next request. So my understanding is that within the first 10 seconds, we won't require any old data. And then after 10 seconds, we'll start requerying that. But during that time, the next 59 seconds, we'll still keep using that old data while we're still requesting the new data. So it's like an upper bound for how long we can continue using the old data. If you're curious to learn more about this, I've included a link. I'll add in the description below that talks a bit more about caching. Yeah, see, stale while revalidate is the maximum caching age possible. Cool. So that is caching. We're almost there. So we learned about server-side rendering. Now let's talk about client-side data fetches. This is for if we want to render any information after the page has loaded. So not like SSR. We just load the page directly, and then once the page is loaded, or we make another request to load the data. So here's an example. So, let's say a user visits the page, we load whatever static information that we have, and then during that process, we make a HTTP request to get data, and then once we get the data back, we re-render our page. So some things to know about this. It can negatively affect the app's load time, and there's also no SEO benefits because unlike server-side rendering where the web page doesn't load until the request is finished, the page is loaded initially, and then the data is fetched afterwards. So the web crawler doesn't wait for that. So any data that you load that's does not get saved, and that's why it's important that we only render non-important external data. So let's go through an example how we use that. So Next.js has a separate library that we install called SWR, which stands for state while revalidate. And what it does is it allows us to make the HTTP request and cache the data. So it implements a state while revalidate strategy similar to what we discussed with SSR. And what it does essentially in 3 easy steps is step 1, if there's any data in it that it has cached from previous queries, it will give that to you. Step 2, it would fetch the new data. And then step 3, when the fetch is complete, we will re-render the UI with the latest data. Here's a link to the example. But if we just look at the code snippet right here, it's pretty straightforward. We use the use SWR function from the SWR library. We give it 2 things: the API endpoint that we want to query, and a helper function to query the URL. 2 data types you can get back is the actual data from the request and the error, if there is any. And as you see in the render function, we, depending on what we get, we render different. So let's implement SWR. Before I click on this link, the goal here is that we want to create a similar experience, a coin price experience as server-side rendering. But instead of loading the crypto price on the server side, we will load the page first, and then we'll fetch the data, the coin price, over time in an interval. And so what we'll see is that the price will change live. And of course, we're going to use Masari to get the price information. So how do we refetch the data over a period of time? If we now open the link and look at the documentation, you can see that SWR has some nice built-in functionality like revalidate on focus. The one that we care about is revalidation on interval. Whenever every couple of seconds, we would add new data. And it's pretty straightforward set. We just include a parameter called refresh interval, and we give it time. And then what this will do is the use the SWR function will query the URL every time interval that you set. So let's do it. So I'm gonna make a new folder inside price, and I'll call it client. And inside of this one, I'll call this client coin price. Just to be different. We can actually use the same name, it doesn't matter, but so let's just copy this, put this over here. And I'm not going to use any dynamic rounding stuff. We kind of already saw it, the home price. Actually, yeah, let's just name this. Instead of this, I'm just going to call this Bitcoin. Because we're not going to do any dynamic routing. We're just going to do a hard-coded search. I think at this point, we all understand how this works. Okay, so let's just make this straightforward. Let's call it a Bitcoin price page. We need to use the, first we need to get the SWR library. So let's close this. So if we go back to our Explorer and we go to package.json, we need to go to our dependencies, and we'll just add in, comma, we'll add in SWR, and the default version is 1.3. So let's end our compiler and just do an npm install. And so while that is installing, let's just continue with the rest of our code. Okay, so we need to import the use WSR. So import use WSR. Oh, wow, perfect. npm will install it for me. Use SWR, and it takes in the API. So we're just going to copy and paste. And I'm just going to hard code. It includes a helper function, so I'm just going to call it fetcher. We'll define this later. And that's it for now. Just like the example, we're going to get our data back. I'm just going to ignore the error, and it's called data. And just for simplicity, if data is not valid, we just return nothing. We don't need any of this anymore. We need to find our fetcher, and you'll see how simple this is. It's pretty much like it doesn't really do anything. So here's what fetcher does. It's just a helper function that takes in a URL string, and this is something that uses this is a callback that use SWR calls, and what it does is entirely up to us. It just expects us to return data back. It's just a one-liner of everything we've been doing up until now, but with the URL that we pass in, i.e. with Bitcoin, we'll fetch the data from Masari. With the data that we get back, we call then to open the promise. We'll get the result, and then we call the .json of the result, and that would return us another promise, which I assume this function would unwrap for us and give us the results back, which is in the form of data. So data essentially is just this whole object that we have, not data dot or not this data, but the object itself. So if we want to get data, it'd be data.data. Hopefully that's not too confusing. So now that we have this, we can just do the same thing that we've been doing. So data.data.name and data.data. Because this isn't an object that we define ourselves, we're actually getting the result back ourselves. We need to actually define the URL path, which is market data and price USD, or not the URL path, but the return item path. So data, market data, price USD. Okay, and so this now will allow us to quickly query Bitcoin information or price data using client-side rendering. Before we do that, we need to do npm run dev again. Okay, servers up. So let's go back to our example. So let's go to price, client, and I called it Bitcoin. Oh, well, Bitcoin with a capital B. You know, I guess that's why capitalization is important. So I'm gonna actually fix that. I don't want to use capital letters. Okay, there you go. So here you go. Client-side rendering. It does the same thing, except it's on the server side. Except we do it after the page loads versus blocking the page load. So now we know how to use this WR. Oh yeah, let's actually do some revalidation. Okay, so if we want to do invalidation, we can do what we just talked about. Pass in a object of options, and we say refresh interval. We'll do 1000. And now we go back here. We can observe that. I'll probably refresh the page first. There you go. Okay, so Masari doesn't give us the data like immediately too. We're also dependent on them updating their data. But every second we are requerying Masari for their price information, and every time we get something different, we just re-render it, as you can see over here. So there you go. All right, so now that we have that, let us continue on. We have one last thing before we're done with this video. So next up, we have the API routes that we talked about. Once again, this is not about our pathing, but this is just literally API requests that we can make. Next.js comes with the capability to build your backend APIs. Here's an example of what it looks like. We export a handler function that takes in two parameter types, the request and the results. And then you just set whatever data you want in your result object or your response object, and then that would get passed back to the sender. All right, so let's get started. So the first thing we want to implement is we want to implement dynamic API routes. So we want to create an API that can take in dynamic data, like like what we were doing with the dynamic pages. We're just gonna replace the client-side rendering with our own API instead of calling Masari directly. Example of this would be we will create an endpoint called API price, and we can query Bitcoin, Ethereum, and so on and so forth. And the goal is once we make that API route, we're going to create a new page to call this API instead of calling Masari directly. So let's do it. So first thing, let's create our API. So let's create a new folder called price, and we're going to create a new file called let's call it coin. I don't have any more uniqueness left in me. So let's go hello and just copy this API definition, and we'll just paste it. And so this actually is pretty straightforward to do. Because the data is inside our URL, all we need to do is we need to extract it. So we just do, gosh, I hate these indentations. We just deconstruct data, coin, and we take that from our request query. And so this coin corresponds to our dynamic name coin right here. And so now that we have this, I will just copy and paste the rest of the code, but it's not any different from what we've been doing. So we gotta make this async, export async, or I think async is right here. There you go. We call it async because we're waiting for our API request to be finished. A very similar thing that we've been doing. We call our response, and then we get our metric data back. And so now our return type, so we give it status 200 because, obviously every call we make is always a success. And we just get our data that we want to return back. We know what all this is. It's data, market, and price USD. And all we need to do is go back up here to our data type and just define this as price. There we go. Okay, there the error goes away. So now whenever someone makes a request as endpoint, we'll use the coin that they specified and search Masari for it, and then we get the response back and then send it back as this data. So now that I have that, let's actually create our front end to call it. So I'm not going to create any dynamic stuff. I'm just going to call this Bitcoin API.tsx. And it's literally going to be the exact same copy of this. The big difference now is that we're going to call our API directly, which is why we use a /. So say API price, and I'm just going to hard code a value. So I'm just going to say, Ethereum. And we'll do the same thing, except now we will, okay, fine. I guess we'll call it Bitcoin because it wouldn't really make sense to call it Bitcoin API. And then all this should work. And I guess to prove that this works, we can do a console.log, and we'll just look at metric. And then if this is correct, it will appear in our console every single time we make the call. Back to the coin API, it's metric.data.marketprice.USD. Okay, and apologies for jumping too much. It's data.price is the expected data that we get back. Too much copy and pasting. Okay. All right, there you go. Yeah, we have to refresh the page, but there you go. Now we are querying our Bitcoin data. It's very similar to what we did. The only difference is now we're querying this, and to prove that this works, we can change this to Ethereum, and now you see that we're querying Ethereum. This is how we would create dynamic API routing. Same thing as we've been doing with the pathing. We just use the brackets, and then we can just query the data from our requests. So here's another interesting thing that you can do. Along with GET requests, we can also make POST requests that passes data from the client to the server. So obviously, we're not supposed to be using POST requests in this specific way. POST requests are meant to, add or update data. Let's ignore that fact for now, and let's just talk about how we would actually send data across the network. So the goal here now is to implement an API route that accepts payloads. So we want to write a POST request that takes in a crypto name in the body to make a price request to Masari and return the value back. And so our endpoint would just be API price. So let's get to it. I don't think it's too different from what we're used to. So back in our API, we'll just create a new file called price.tsx. Actually, interesting. It should be price.ts, not tsx, but it's interesting that it actually works. API. That's great. Anyways, so inside our price, it'll be pretty much exactly the same thing that we've been doing. So let's go to coin and go and paste. And so to access data, we'll see how this makes sense on the client side, but on the server side, whenever we get data, all the data should just store in the body. So literally what we have to do here is instead of doing request.query, which searches your URL, we just do body, and then we just get the data that we send. There's no correct way, unfortunately, of getting type. I'm sure there is, but yeah, you probably just define the data type you expect in here, but I'm not gonna do that. I am guaranteeing that I am sending a request with the data type coin. Or actually, no, that we just get the data itself, and then we do the same exact request that we've made with the dynamic routing, but with POST request this time. Okay, great. So that's straightforward enough. Let's talk about let's actually make the page do that. So this is let's just call it Bitcoin post.tsx, and this will be literally the same copy and paste of our Bitcoin API. I probably should call it Bitcoin get. Actually, let's just do that. I'm gonna rename this. It's called Bitcoin get. So Bitcoin post is slightly different. Oh, first we need to change our API to be API price, not the dynamic one. And so the interesting part now is how do we actually pass the data in our fetch? So if you look up, the fetch API, you'll find out how to do this. It's not hopefully too difficult. All we need to do is inside our fetch request, we need to define some parameters, our options, I guess. And the things that we need to do is we need to include our body data. We need to include string, a JSON object. That is why we use JSON.stringify. And what we're stringifying is this object called coin. Remember, this is the coin that, I'll define this, coin Bitcoin. But this coin param is this coin that we are using over here. And so we pass in our body. Our method is a post request. And I don't know if we need to set the headers, but it's common to set the header type, which is content type. This is the type of data we should expect, and it's application/JSON. So this is just copy and paste. Don't worry if you don't know this. And then the rest is actually the same. So now we make a post request. All right, okay, I figured out the problem. I did some print debugging, and what I found, if I just hard code some return, is that if I did a console log on my coin to see what I'm passing in, I found out that I'm actually passing in nothing. And after looking around, I found out the problem. It's because I spelled application wrong. Now, if I save that and I try again, there we go. We get the one that I hard coded. So let's do this, and I do metric dot data dot market data dot price USD. All right, this should work now. I just refresh, and there we go. Now we are able to make post requests. So once again, to prove that I've done this correctly, we go to Bitcoin posts, and let's say we look for Sol instead. I have to load the, oh, there we go. So yeah, there you go. Now we get the Solana price, and it refreshes every second or so. And yeah, there we go. Let's go back to slide. So yeah, that's about covers everything we want to implement in this. Hopefully now you are a Next.js expert and you are ready to make your next dApp. Why did we come in and do all of this? And even though it's a crypto channel, I'm wondering that to myself again. But once again, it's too late. We already got this far. Not stopping now. So here's our conclusion. Here's what we learned. So we learned what Next.js is. We explored some of the alternative front-end framework solutions. We set up a new Next.js project. We learned about page routing. How do I visit the page? We learned about dynamic page routing. How do I visit like blog posts and stuff like that? We learned some of the components, the HTML and CSS modules that Next.js provides. I'm not going to dive too much into that because, I think that we are all smart enough to figure that one out. Big things that we really dived into is the different rendering and data fetching strategies. So we have static site generation, which is good for pages that don't change too often. We talked about ISR and how we can regenerate existing pages that we've statically created. We talked about server-side rendering and how that works great for for dynamic data, and how we can also cache that data, so making it more like static site generation. And then, of course, we talked about client-side data fetching, which is us loading the page first and then fetching the data later after the page load. And then, of course, we talked a bit about Next.js's API backend functionality. We learned how to have dynamic routes. I'm sure we can all figure out how to do static routes, so let's not worry about that. We learn how to make API that accepts post requests with payloads. And that's it. So what's next? Well, after I don't know how many months it's been, we're going to dive into the Create Solana app that the Solana team has introduced. What essentially it is, it's a Next.js template for, I say Phantom Wallet because I'm highly biased, but for a Solana wallet integration with basic functionalities. It has some suggestions on how to structure your apps. And more importantly, it has some Anchor integration, so you can keep your Anchor code there and talk to it. Here's a link to the application itself, how to get started. If you don't want to wait maybe the next couple of months before I finally get my act together. But yeah, that's what we are in store for the next video. Sorry that it took this long to make the Next.js video. I would promise that I would do better to crank out more content, but let's just look at my past track record. That's probably not feasible. But I will persevere. It's definitely not because I have waning interest in Solana or Solana development. It's just other personal things that are taking my time. Stay tuned for the next video. If you enjoyed this content, please give a like and subscribe if you haven't. Otherwise, I'll see you in a couple months from now, or hopefully sooner. See ya.